Welcome to lecture number 5, R.5, Rational Exponents and Radicals. Okay, so, first objective is factor out the greatest common factor. So we're going to take a look at sort of an example that doesn't really have math in it, and then we'll go ahead and look at some actual math examples. So for the first example, imagine that there are 3 siblings, Keone, Kea, and Lily. So Keone has a mustache, curly hair, glasses, and a hat. Kea has a mustache, curly hair, and a hat. Lily has glasses and curly hair. What do they all have in common? So I'm going to go ahead and draw this out. Let's see. We have Keone. What does he have? Curly hair? Let's just go ahead and give him some curly hair here. What is this he has? He has a mustache. Glasses. And a hat. Oh, darn. Used up the hair there for the glasses. Used up the spot for the hat right there. So here's his hat. Okay. That's Keone, my wonderful artistic rendition. And then we have Kea. What does he have? He has a mustache, curly hair, and a hat as well. But he doesn't have glasses, so there's his little eyeball. And then Lily has glasses and curly hair. And we're asked, what do they all have in common? Well, the one thing, at least one of the things I noticed they all have in common, is the curly hair. Is there anything else in common that they have? No, that's it. So the greatest common factor that they all have, GCF, greatest common factor is curly hair. Nothing else was a common factor, so we left it, but the main thing was the curly hair. So same idea that we're going to do for math. We're going to take a look at all the terms and figure out what they have in common. So for example 2, we're going to identify and factor out the greatest common factor. So we're going to go ahead and treat the 2x and the 4, so the 2 different terms, pretend they're the siblings. First, we're going to factor them. We're going to take a look at what they have. The 2x, when I factor it, which means we're breaking it down into the smallest parts, is just 2 times x. The 4, that can be simplified into 2 times 2. So we're looking at them, and what do they have in common? Well, they both have at least one 2. Now, you might be tempted to take out both 2's, but remember, this one only has one 2, even though that has 2. So the greatest common factor, oops, wrong way, GCF, is 2. Okay, that's great. So now what we're going to do is factor out the 2. So when we take away 2, what is left over? Just the x, bring down the plus sign, and then the other 2. Alright, so I'm going to go ahead and rewrite that here a little nicer. We factor this into 2x plus 2 times 2, which is 2 times x plus 2. And there we have our answer. Okay, so it's one part to identify, the other part is to factor it out. Now let's take a look at B. So this one, there are 3 terms now, and they're a little more complicated. But still, same plan happens. Factor, see what they have in common, and take it out. So this one factors into 2 times 3 times x times y. And the other one factors into, let's see, 2 times x times y. I'll go ahead and bring down that plus sign and that plus sign. And the last one, the 2x, the 12x, sorry. 12x, that can be simplified into, let's say 12 is 2 times 6, but the 6 can be simplified into 2 times 3. So 12 can be simplified into 2 times 3. And then the x. Alright, let's take a look at these. Pause the video, see if you can find out the greatest common factor. Okay, so taking a look, let's see, what do they all have in common? Well, they all have one 2. They don't all have a 3. Ooh, they all have one x. Do they all have a y? No, this one doesn't have a y. So what do they all have in common? So the greatest common factor is 2x. So that's what we're going to take out. So taking out the 2x, and what's left over? The 3 and the y. Bring down that plus sign. Take out the 2 and x, what's left? The 2 and the xy. Bring down the other plus sign. Take out the 2x, and what's left? 2 times 3, which is 6. Alright, there we go. Factored out the GCF. Okay, let's take a look at this next one. Ooh, this one's pretty fancy, but I'm going to go ahead and be careful to see what the terms are. So this is one term. And then, ooh, we have this other larger term. So these terms are actually factored. It may not look like it, but it actually is. I'll go ahead and write this out. This is 2 times y plus 1. This cannot be factored. And then plus, this other one is 5 times y plus 1 times 2y minus 3. So do they have something in common? Well, this one has a 2, but the other one doesn't. Oh, this one has a y plus 1, and that one has a y plus 1. So that is my GCF, the binomial y plus 1. So let's go ahead and factor that out. And what is left over? Cancel that, we're left with 2y. Cancel that, we're left with 5 times 2y minus 3. And we can leave it like that. If you want to, you could go ahead and multiply this out. Let's go ahead and do that next step. Y plus 1 times 2y plus 10y minus 15. And then we could go ahead and simplify the y's together. And left with y plus 1 times 12y minus 15. And there we are done. Okay, let's take a look at the next objective, objective 2. Factor by grouping. Okay, so this is one of the many factoring methods. Example 3, factor the following by grouping. And this is usually, note, usually used for 4-term polynomials. Okay, so as the plan suggests, we're going to take a look at these and group them. Okay, grouping, we're basically just going to plop in some nice little parentheses. So I'm going to go ahead and group the first 2 together and the second 2 together. It doesn't always work out this way, but most of the time in this class, this is how the grouping will work. If it didn't work the first way, you could go ahead and reorder the terms around and see which grouping worked. But once you do that, you're just going to focus on each term individually. Sorry, each grouping individually, and see if they have anything in common. So for the first one, do they have anything in common? Well, they both have a 2. Remember, this is 2 times 3. And they both have an a. So I'm going to go ahead and factor out a 2a. And what's left? Just 1x minus 3y. I'll bring down the plus sign. Now let's look at the other grouping. I could take out a 5 from there because the 15 is 3 times 5. And there's nothing else they share in common. So what's left over when I take out the 5 is just x and then 3y. Remember that minus sign. Okay, so once I've done this, you might be tempted to stop, but this one looks an awful lot like the one we just did above. Notice we now have 2 groups again, or 2 terms, and each term actually shares a common factor, the x minus 3y. We'll go ahead and take that out. And what's left over? Well, the 2a plus the 5. And there we go. We're done. Not too bad. Let's take a look at one more example. So notice one thing here. The main thing to note here is that there was a plus sign in the middle. So we were able to easily just put parentheses in and work. But sometimes you may not have a plus in the middle. So you have to be careful with that. Let's take a look at this next one. I'm going to go ahead and do my grouping. But all of a sudden I'll notice there's a minus sign in the middle. So I can't just easily throw parentheses into this. Why? I'll show you in a sec. If I was to just throw parentheses in without doing anything else, what would I get if I tried to check to make sure I hadn't changed my problem? Okay, so this is if I just threw in the parentheses and didn't do anything else. If I was to try to go ahead and get rid of the parentheses by using distribution, which we know how to do, I would get negative 2x squared. Oh, negative times negative plus 4y. Was that what I originally had for my problem? No, it's not. That's supposed to be a negative 4y. That's what we were originally given. So we did something wrong. The reason is when you put up those parentheses, you have to find a way to balance out the need for the minus. So to do that, when you plop in that minus sign, what you're going to do is change whatever sign this is to the exact opposite. In this case, it's going to be a plus. Okay? So if you're ever doing groupings and there's a minus sign, you need to make sure to change this sign. Why? Because we're adding in the parentheses. Okay. Let's go ahead and see what we can factor. Looking at the first group, they both have an x, so I'll go ahead and take out the x, and that's what's left. The second group, let's see, they both have 2. So we'll take that out. Now I'm going to see if I can go ahead and take out a factor. But when I look at this, none of these factors are the same. So I can't do anything. Okay, so the problem must be that I've grouped these wrong. So I'm going to go ahead and try regroup these and see if I get a better chance of factoring. So let's go ahead. I'm going to go ahead and pair the 8x and the 2 together, and then pair the xy and the negative 4y together. Okay, let's go ahead and go with that. But let me go ahead, I'm just going to rewrite it one more time. Let's do the 4y in front. Okay, so now let's go ahead and do the grouping once more. And when I do the grouping, notice I still have that minus sign there, so I'm going to have to change this. And that time I'll change it to a minus. It's always just the opposite whatever was there. Alright, let's go ahead and factor this. So I can take out a 2x, and I'm left with 4 minus x. Then minus. From this one, I can factor out just a y, and I'm left with 4 minus x. Alright, so now let's take a look at these two terms. Do they have any factors in common? Oh, they do! They both have the 4 minus x in common. Okay, so this time the regrouping worked. Alright, so let's go ahead and take out the 4 minus x, and what's left over is the 2 minus y, or the 2x minus y. And there we go. You're done. So box our answer. Now the third objective is factoring quadratic trinomials. Alright, so we're going to factor the following. So the method for factoring quadratics, it will depend on a few things, but first you always want to make sure that you have your trinomials from highest power to lowest power. So you have y squared, a y to the 1, and then y to the 0. First make sure you have that. And then what we're going to do is first, let's set up the parentheses that we're going to try to factor into. After that, we're going to look at the signs in the problem. We have a plus and a minus. Okay, so normally when we do the FOIL, remember F-O-I-L? First, outside, inside, and last. The OI product is what gives us the middle. Okay, so because of that product that gives us the middle, we're going to go ahead and take a look at the factors of 14 and whatever's in front of the squared value. In this case, it's just a 1. So the factors of 14. So right now it's just sort of educational guessing. So let's see, factors of 14, 1 and 14, 2 and 7, and I think that's it. Okay, so once I've done my factors, so first factor. Second, I'm going to find the question. So the question is, what do you add, or what factors of 14 do you add to get a negative 9. So, what factors of 14 that's a weird do you add to get a negative 9? Well, let's take a look. So one thing to note is that for our L product, remember in FOIL, the last one, L, I have a positive. The only way to get a positive 14 is if you either have two negatives, because when you multiply negative times a negative, you can get a positive, or if you have two positives. Okay, I'm going to say we need two negatives. Why? Because I want to get a negative 9. Okay, so we're going to be adding negative numbers, so I'm just going to go ahead and plop these in. Negative 1 plus negative 14, that's negative 15, so this doesn't work. How about this? Negative 2 plus negative 7? Hey, that is negative 9. So those factors work. So we're going to go ahead and plug those in. It doesn't matter exactly which one. We could do negative 2 and negative 7. And then the y value. Right now the y doesn't play much of a part because it just has a factor of 1. When you actually get a number in there besides 1, then you'll have to do a little more guesswork in the factoring section. Okay, but there we go. So how would I check my answers correct? Well, you could go ahead and FOIL it out. I'll do it right here. So here's our checking to make sure we're correct. Doing FOIL, first, y squared, outside, inside, and last. Adding the two together, y squared minus 9y plus 14. Is that what we had? Yep. Okay, so we factored it correctly. So just a good way to check your work. You can just go ahead and multiply it back out. Alright, so taking a look at the next one. It's not in the right order yet because we're not in descending power. So I'm going to rewrite this so we're in descending power. 6k squared plus 23k plus 7. Okay, so just setting up my little parentheses here, I'm going to determine the signs first, pluses or minus and whatnot. Well, I have a plus sign. So I know these are either going to be both positives or they're going to be both negatives. How do I know which one? Well, remember, the middle number is when we add up the values, and it's positive. So because the middle number is positive, these are both going to be positives. Alright, so now we're going to go ahead and do the factoring. But right before that, the question is, from the factors of 6 and 7, what do we add to get 23? So how do we add to get positive 23? If this was a minus sign here, we would be saying, how do we subtract? Okay, so factors of 6 and 7. Factors of 6 are 1 and 6 and 2 and 3. Factors of 7 are just 1 and 7 because 7's prime. So now we move into a little slightly more complicated step than the first problem because we have an actual number higher than 1 by our squared value. So I'm going to pick one factor from each team, you could call it, first and last coefficient, and see, using some different ways of multiplying, can I get positive 23? So I can go ahead and multiply crossways. So 1 times 6 is 1. Sorry, 1 times 6 is 6. 1 times 7 is 7. Can I add these to get 23? No, that's 13. Okay, that method didn't work. We have one other option with these pair. If it doesn't work, this pair doesn't work. 6 times 7. What is 6 times 7? That's 42. And 1 times 1 is 1. Can I add those two to get 23? No, that's going to be 43. Okay, that pair didn't work. So the only other option actually I have is going to be the 1 and the 7 and the 2 and the 3. Let's go ahead and try both ways. We have the crisscross way and then the around. So 2 times 7 is 14. 1 times 3 is 3. When I add those up, I get 17. Okay, that's not right. Last chance, and if this doesn't work, then this item is going to be prime. We're not able to factor it. So 2 times 1 is 2. 7 times 3 is 21. Hey, when we add them up, we get 23. We found our golden pair. 7, 3, and the 2 and the 1. Now the question is, where do we put them? Well, remember, the 2 and the 3 came from the 6, so these are the k values. And we put the k values first, so we have a 2k and a 3k. And then after that, the 1 and the 7 came from the end value that does not have variables. And remember, this all comes from the OI product in foiling. Outside, inside. Okay, so the 2 got multiplied to the 1, so we're going to put the 1 here. And the 7 got multiplied to the 3, so we're going to go put the 7 with the 3. Alright, and there we go. We have our factored version. So if you wanted to check this, you could go ahead and multiply it out and make sure we got the right answer. One last one here. So, those numbers are really big. One thing you always want to do first when you're factoring is to take out the greatest common factor if possible. All of these has a 0, so I know they're all divisible by 10. So I'm going to factor out a 10, I know that. Now let's take a look at all of these values. Do they have anything in common? Well, they all have an m, so I'm going to go ahead and take out one m. What's left over? 3m squared minus 20 mn minus 7n squared. Okay, so we did that. So now I'm going to look at this. Can I factor this? Well, it's a trinomial. So we know how we can try and factor it. Trinomial, huh? Okay. Let's see. Well, the question we're being asked here is how can you subtract to get a negative 20? So subtract to get a negative 20. Well, in order to find this out, we're going to have to go ahead and take the factors of 3 and 7. So the factors of the 7n squared is going to be 1 times 7 because that's prime. And the factors of the 3m squared is just going to be 3 times 1. Oh, they're both prime. So this is easy. We just take these two. If it doesn't work with them, then we know it's prime. So we have the 1 times 7, the 3 times 1. Let's go ahead and use the crisscross method first. So we have, let's see, 3 times 7, that's going to be 21. And then we have 1 times 1. And we're told to subtract. Now one thing I forgot to do is, what are the signs going to be? Are they both going to be pluses? Well, remember, in order to get the last term, you're multiplying the two last ones. That's the L in FOIL. But a positive times a positive would never give us a negative. So that doesn't work. What about both of them being negatives? We still run into the same problem. Negative times negative would not give us a negative. So we know one has to be positive and one has to be negative. Alright, so looking at this, I want to get a negative 20. So that means I should put the negative with the 21 and the positive with the 1. Because then negative 21 plus 1 gives me the negative 20. Awesome. Now we just have to figure out how to plug these in. Let's see. The 1 and the 7 were with the n's, and the 3 and the 1 were with the m's. Okay. But let's see, the negative 21 came from the 3 times the 7. Okay, I'm going to keep that in mind. So I'm going to go ahead and erase this. Let's see, the m's were first, so I'm going to go ahead and plug them in first. So I have the 3m and the 1m. I'll just go ahead and write m. 1m and m are the same. And then we know we're filling in the O and the I products. So that's 3m times 7n. And we want that negative 21. So we're going to go ahead and put that negative, because we need that negative 21, and then the 7n. And lastly, we're almost there. We have the 1 times the 1. So that's going to be 1, and it's a positive. Oh, okay, so lots of little steps. But thankfully, you can pause this video and check again. One of the main differences here was that our end term actually had a variable itself. That made it a little more difficult. But if you follow the same method, you should be able to get there in the end. And as usual, if you ever run into trouble on the homework, just send me an email. Okay, so let's take a look at the next page. This was an added addition to my notes. There was a new one uploaded, so make sure you have the right notes. So the next objective is factoring binomials. So there's one method which we are familiar with, which is the difference of two squares. That's if you have a squared minus b squared. This factors in the two conjugates, a minus b times a plus b. Now, the difference of two cubes looks like a cubed minus b cubed, so very similar, but notice it's a cube. And the sum of two cubes is a cubed plus b cubed. So these factor into ways that look very similar, but there's a slight difference, so pay attention to the plus and minus sign. The first one factors into a binomial with the exact same sign as what it originally had. And then it factors into a trinomial, and the trinomial should always be prime, as long as you made sure this was factored before you did that. So the trinomial should always be prime. And then we'll get a squared. Now this is where the sign changes. So instead of a minus, it's going to become, in this case, a plus. Then we have ab plus b squared. The next one would factor into a squared minus ab plus b squared. Okay, so notice the form is pretty much the exact same for both of these. The only difference is the signs. So the way they remember it is the first one is the same, then you change, and then it's positive. Okay, so you copy it. Same, change, positive. All right, so let's take a look at these. So the first one, let's see, what does this look like? Well, it's a binomial, so two terms. There's a minus sign. Oh, and I see a square, so I think this is going to be the difference of two squares. Let's see. Can I write this as two things squared? Well, this is t squared minus, and let's see, 121. That's 11 squared. So I have found my a and my b values. Here's my a value is t, and my b value is 11. So we can go ahead and factor this into a minus b, so t minus 11 times the t plus 11. And there we go, I have my 2 factored right there. Let's take a look at the next one. Well, one thing to always check is to make sure you can take out any common factors. And I notice these both have a z. So I'm going to factor that out first. Now let's take a look. This is a binomial, so I want to make sure that I can factor it. If I can factor it, I'll go ahead and factor. If I can't factor, then I'm good, it's prime. So let's see, it's a minus sign, so it's either difference of squares or difference of cubes. Well, the 1, that's a perfect square and a perfect cube, so that doesn't help us much. Let's take a look at these two. 64 is 8 times 8, and z to the 6th power is, z to the 6th power, that's z cubed squared. Okay, so this is the difference of two squares. So let's go ahead and I'm going to factor it out on the side first. So 64 is z to the 6th minus 1. That's 8z cubed squared minus 1 squared, which I can factor to 8z cubed minus 1, 8z cubed plus 1, the conjugate pair. So you might be tempted to say we're done, but notice, once again, it's a binomial and there's a minus sign. This is also a binomial with a plus sign. That fits either one of these options, so I need to make sure that none of these are perfect cubes or perfect squares? Well, let's see. They both have a 1. So that would fit the definition of being either difference of squares, cubes, or sum of cubes. Let's take a look at the 8z cubed. Well, there's a cube here, so I know it's not going to be the difference of two squares. So that leaves me with two options. It's either difference of two cubes, sum of two cubes, or it's prime. Let's see. In this case, it would possibly be a difference. So let's see. Is 8 a perfect cube? It is. 8 is 2 cubed. So this is the difference of two cubes, and this is the sum of two cubes. Let's go ahead and factor those on the side, and then I'll put it into my problem. Okay, so we need to identify the a and b values first. So it's going to be 2z cubed minus 1 cubed. So, factoring this out, we have the minus sign, so it's going to be the a minus b, a squared, so that's 4z squared, plus ab, so that's 2z, plus b squared, which is going to be 1. Okay, so that one's factored. I'll go ahead and plug that in. So this one factors into 2z cubed, 2z. 2z minus 1 times 4z squared plus 2z plus 1. The next one. Let's see, we can use the same idea here. So those are my a and my b values. And that factors into 2z plus 1, 4z squared minus 2z plus 1. Alright, let's go ahead and write that in. 2z plus 1, 4z squared minus 2z plus 1. And there we go, we factored that out. That is pretty intense. Very long. Okay, so all of this to say we want to apply a general strategy for factoring polynomials. The first step we're always going to do is factor out the greatest common factor if possible. And then the next thing we're going to look at is the number of terms. We group it into 4 terms, 3 terms, or 2 terms. If you have 4 or more terms, the technique you would use is grouping. Either 2 by 2 or 1 by 3. The next one, for 3 terms, you're going to use trinomial factoring. And lastly, if you had 2 terms, we're going to use one of the above, which would be difference of cubes, difference of squares, or sum of squares. Okay, right there is your battle plan. First, factor, then see how many terms you have, and then finally, apply one of the factoring techniques. If none of the factoring techniques works, then you can say it is prime, unfactorable. Alright, so let's take a look at the next and almost last example. Factor the following using 1 by 3 grouping. Okay, so what does that mean? Well, put one term by himself and then 3 in the other group. So let's go ahead and do that. First off, please note there is a small typo in my problem. There should be a 4 right there. Okay, so taking care of that. Now we're going to go ahead and group it. So here's my 1 term, and then I'm going to go ahead and put in my 3 terms. But a red flag should have popped up in your head. I put a parenthesis in front of a minus. That means I have to change the signs on the inside to the exact opposite of what they were. Okay, let me go ahead and write this out a little clearer. Alright, so looking at this trinomial, can I factor this? Well, we're looking for factors of 4, then when I add them together, I get another 4. Well, I can factor that. That'll be 25 minus, and this can factor into x plus 2y, x plus 2y. Okay, that would we call a perfect square trinomial. Hey, these two are exactly the same. So I could be sort of clever and write these as x plus 2y squared, because there's 2 of them, right? Alright, so I'm going to check and see, can I do any other factoring? Well, this is a binomial. There are 2 terms. And there's a minus sign. So this could possibly be the difference of squares or the difference of cubes. Well, that's a square, so it can't be this one. It's possibly a difference of squares if that's a perfect square. And it is. That's 5 squared. This is 5 squared minus x plus 2y squared. I have the difference of squares. Okay, so I'll go ahead and set this up. Let's see. My a value is 5, and my b value is this really big binomial, x plus 2y. So factoring this out, remember, it factors into a minus b times a plus b. So using that form, my a value, 5, minus my b value, which is x plus 2y. Next terms, my a value again, this time plus my b value, which is x plus 2y. Alright, let's go ahead and simplify that on the inside. Let's see. We have 5 minus x minus 2y, and then 5 plus x plus 2y. Now, will we start multiplying this out? The answer is no. We're trying to factor it, so don't do any multiplying. Okay, there we have it. We're done. Now the last one. Factor the following using U substitution. Okay, so this is a fancy new way. Basically, using U substitution, our goal is to make the problem look less complicated. Okay, so right now it looks really complicated. It's huge. But one thing I noticed about this problem is these little binomials here. One of them is the square of the other. So I can use this. What I'm going to do is I'm going to say, let u equal x squared minus 2. Hopefully this will simplify my problem. So I'm going to go ahead and replace x squared minus 2 with u. Let's see if this makes my problem look a little less insane. Oh, it looks a lot smaller, doesn't it? That looks like a regular trinomial that we're used to factoring. So let's try factor this. That's going to be, let's see, I want to use factors of 14. That'll give me 5. Factors of 14. 1 and 14, 2 and 7. Well, if I subtract 2 and 7, I can get 5. Alrighty, there we go. So I found the factors. That'll be u plus 7, u minus 2. Alrighty. So you might be tempted to say we're done, but we have to go ahead and plug this back in for u, because remember, we started out with u. So resubstituting this back in for my final answer, I get x squared minus 2 plus 7, and then the x squared minus 2 minus 2. Lastly, let's see if we can simplify the insides. Well, these guys are like terms, and these guys are like terms. Let's go ahead and simplify that. Okay, let's see. Can I do any other simplifying? Well, I have a binomial. The only way to factor a positive binomial is for difference of cubes, and that's a square. So that's not going to be a difference of cubes. Can I factor this one? Well, it has a minus sign, so it's either the difference of cubes or the difference of squares. And this is a square. Ah, this is a difference of squares, so we have to simplify that one. We got to factor it. Okay, so this is going to factor into x minus 2, x plus 2, the difference of squares. And that's it. We're done. None of those are any of the difference of squares or difference of cubes, so we're done. And for Objective 6, we don't cover that in this course. We're going to cover that in Math 135. All right, that is it for this section. Please email me if you have any questions.